Hey guys, hoping all is well with everybody. In this video, we're going to be continuing with the practice algebra exam, starting with question number 22. Question 22 states, what are the solutions to the following quadratic equation, x squared minus x minus 56 is equal to 0? And then we have our answer banked down here on the left. Now, there's two ways that you can approach this, and what it really comes just down to is what you're more comfortable with. The two ways that you can approach this are using the quadratic formula to directly solve for your roots. There's going to be two of them, as the quadratic equation always results in two solutions. The other technique that you can use is factoring this quadratic and then setting each of your factors equal to 0 and solving for your roots. So I'll definitely be showing you each of the steps in each of these techniques, but before we do so, let's just recall that, remember, all quadratic equations take the form ax squared plus bx plus c equals 0. And that a, b, and c are just the leading coefficients of each of the preceding terms. So remember that if a variable doesn't have a coefficient in front of it, we infer it and understand it as 1. So I'm going to go ahead and put a 1 here and a 1 here. Now remember, for a, b, and c, not only do they take the value, they also take the sign. So let's go ahead and identify right now what our a, b, and c are for this quadratic equation. So our a is going to be 1, and it's going to be positive 1. For b, it's going to be 1. Because this is subtracted in this quadratic, it's going to take that subtraction sign and make this value a negative coefficient. So it's going to be negative 1. And then last but not least, c is going to be negative 56, as we have the value of 56, but it does carry the negative as well. So negative 56. Now, as I mentioned, we're going to be going over both techniques, and let's do the quadratic formula first. So remember, the quadratic formula is going to allow you to directly solve for your roots. So recall that the quadratic formula is going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, for those of you who don't know and have never heard it before, there is a much easier way to remember this equation, as it can be kind of intimidating to try to memorize. There is a song that goes with this to the tune of Pop Goes the Weasel, and it allows you to remember the quadratic formula a lot easier. Here's how it goes. X equals minus b plus or minus the square root b squared minus 4ac all over 2a. And that's a little song that you can kind of remember to allow you to remember that formula. But again, this method is a lot of plugging and chugging. So let's go ahead and start plugging in the values. Remember, a, b, and c here are just going to be corresponding to the coefficients of your quadratic equation. So this is going to be the negative of negative 1, b is negative 1, plus or minus the square root of negative 1 squared minus 4 times 1, a is 1, negative 56 is c. So we have negative of negative 1 is going to be 1. I'm going to go ahead and start simplifying as we go. Plus or minus the square root. Now be very careful here. Negative 1 squared is positive 1. Subtracting 4 times 1 times negative 56, and that's negative 224. So we're going to be subtracting negative 224, which is like adding 224. This is going to give us 1 plus or minus the square root of 1 plus 224 over 2a. This is going to give us 1 plus or minus the square root of 225, and the square root of 225 is 15. So we're going to do 1 plus 15 over 2 times 1. And we're going to do 1 minus 15 over 2 times 1. Now, kind of bringing this back up here so it's a little easier to see. Solving the arithmetic, we have 1 plus 15 is 16 over 2, and that's 8. And then we have 1 minus 15, which is going to be negative 14 over 2, and that's going to be negative 7. So the roots or solutions to your equation are going to be equal to negative 7 and positive 8. And the answer for that one is actually going to be choice B. X equals 8 and x equals negative 7. I accidentally wrote it wrong in the beginning. But here's how you can check to make sure that that's true. Go ahead and plug each of these solutions into this equation. 8 squared is 64 minus negative 1 times 8 is going to be negative 8. So 64 minus 8 is 56. Minus 56 is 0. This one works. Let's do negative 7. Negative 7 squared is positive 49 minus a negative 7 is going to be 49 plus 56, or 49 plus 7, which is 56, minus 56 is equal to 0. So these do work when we plug them into the original quadratic. So that's the first way that we can solve for the solutions of a quadratic, is using the quadratic formula. Let me introduce the other way. The other way is actually very similar and linked to the quadratic formula, but it is a little different in terms of the number of steps and its approach. What I'm going to do for the second technique is I'm going to make a table. This table is going to be composed of a left and right side, as all tables do, where the left side is going to be the product or multiplicative outcome of A and C. So I'm going to do A times C. What we're trying to do is we're going to take the factors of the multiplicative outcome of A times C and take the sum of them to equal B. So this is going to be the sum to B. So let's go ahead and put our values in. So 1 times negative 56, A times C is negative 56. And then the sum to B, so it's going to be negative 1. So to illustrate this a little clearer, we're going to take the factors of negative 56 that add up to B, and then we can go take those factors and solve for our solutions to this quadratic equation. So what we're going to do is we're going to take the pairs of factors that multiply to negative 56 that when added are going to be equal to negative 1. That's what we're shooting for. So let's go ahead and just start listing all of the factors of negative 56 in pairs. And there's quite a few of them. So just recall very carefully that if you have a negative product of A times C, you're going to have one factor that's positive and one that's negative. So we're going to have negative 56 and positive 1. We're going to have negative 1 and positive 56. We're going to have positive 2 and negative 28. We're going to have negative 2 and positive 28. We're going to have positive 4 and negative 14. We're going to have negative 4 and positive 14. We're going to have negative 7 and positive 8. And we're going to have positive 7 and negative 8. These are all the factors, pairs of negative 56. Now what we're going to do is we're going to take the sum of these, we're going to add these pairs together, and we're going to try to figure out which pair of factors is equal to negative 1 when added. So let's go ahead and start at the top. Negative 56 plus 1 is negative 55. This is not equal to negative 1, so this pair of factors doesn't work. Negative 1 plus 56 is positive 55. This also doesn't work. And we're going to just keep going down the line till we find a pair of factors that equals negative 1 when added. 2 plus negative 28 is negative 26. That won't work. Negative 2 plus 28 is positive 26. That one won't work. Positive 4 and negative 14 is negative 10. That one won't work. Negative 4 plus 14 is positive 10. That one won't work. Negative 7 plus 8 is positive 1. That one won't work. But positive 7 minus 8 is negative 1. And that does indeed work. But notice how these positive 7 and negative 8 are kind of flip-flopped to our last technique. What we need to do now is take these factors, set them up as a binomial expression with the variable x, and use that to solve for the solutions. Here's what I mean by that. What we're going to do to set up a binomial expression is take the variable x and then just add on the value with its corresponding sign. So we have x plus 7 and we have x minus 8. We're going to set these both equal to 0. Now, before I do that, what I want you to kind of see is that if you were to take x minus 8 and x plus 7, we know that this group of factors works because if we FOILed out x minus 8, x plus 7, we would get our original quadratic by using the FOIL method. First is going to be x squared, outer is going to be plus 7x, inner is going to be minus 8x, and then last is going to be minus 56. And then when we simplify, we'll get x squared minus x minus 56. Plus 7 minus 8x is going to give us that negative 1x. But now we can go ahead and solve for the roots of this quadratic, just as we did with the last technique. We're going to set this one equal to 0 though, and that's going to allow us to find the roots. So this is just basically a one-step equation where we can just isolate the variable by undoing what's being done to it. We're going to have positive 7 added, so we're going to do the inverse and subtract 7, and x is going to be equal to negative 7. And then x minus 8, we're going to add 8 to both sides, and we'll get x is equal to positive 8. So again, our roots are going to be x equals 8 and x equals negative 7. So as you can see, both of these techniques work. They're both very proficient and efficient in allowing you to solve for your solutions of a quadratic. Again, it just comes down to whatever is more comfortable for you. A lot of the quadratic formula involves square roots, but other than that, they're both very usable and efficient ways of allowing you to solve for quadratics. But because this is such a long kind of problem and I demonstrated both ways, I'm going to just end the video here. And again, if you guys have any questions or would like example problems of finding solutions to quadratics, I'd be more than happy to do so. But I hope this video helps you guys out. And again, our answer is going to be choice B. But again, if you guys have any questions, please don't hesitate to contact me. And I hope this video helped you guys out, and enjoy the rest of your day. Thank you so much for watching. Take care.